We have, want to do x first? Okay, so x goes from 0 to 1, y goes from -3 to 3, so we've got x, y squared plus 1, dx, dy.
Use substitution.
U substitution?
U equals x squared plus 1.
You want to do what?
X squared plus 1.
U equals x squared plus 1, yeah. Du is equal to 2x dx. Can we just fail at this first or find out if it works? Let's do that first. Dx equals du over 2x. So what do we have to do here? -3 to 3, but then what changes? Hint, 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 hint.
Limits.
1 to what? To 2 of x, y squared over times du over what magically goes away? That's so awesome. So that's 1/2 integral from -3 to 3, integral 1 to 2 of y squared over u du dy, right? Nice. I'm liking this. So now we integrate with respect to u, and you end up with 1/2 -3 to 3 of what?
The absolute value. The ln of the absolute value of u.
Of u, correct, times
Y squared.
y squared from
0 to 1.
1 to 2.
Sorry. Yeah.
0 would cause a problem. Why?
It doesn't exist.
0 exists. Be more specific.
The natural log of 0.
Correct. Thank you. So what does this equal? 1/2 integral -3 to 3 of ln of 2, and there's a y squared out front, correct? Is that correct?
Yep.
I think it's okay. So then we integrate with respect to y.
We'll pull out the ln of 2.
That's good. So we have ln 2 over 2 integral -3 to 3 of y squared dy. We end up with ln 2 over 2 of 1/3 y cubed from -3 to 3, right? So we plug in 3, we get 27 as 9. So we end up with ln 2 over 2. We end up with what? 9 plus 9? Is that correct? Is that correct? So it seems like this is going to come out to be 9 ln 2.
And the book says...
Yeah, that is the question, isn't it? This isn't anything yet. We need some limits and we need an order of integration, right? So how about I just go, oh, it's going to be 0 to 1 in both of cases, right? So it doesn't matter which one I put where. It's the same thing.
Let's do x first.
Let's do x first. Doing x first seems nice. And what is it going to be? U substitution. U is equal to x squared plus y. So du is equal to 2x dx. And it comes y, yeah, because if you differentiate y, it's going to be 0, right? It's a constant. So dx is du over.
These are really partial derivatives in a way.
Yes, 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 absolutely. So it's going to go 0 to 1, 0 to 1 of x square root of u dx dy, right?
I think from then on,
Are you pretty good from now on? So instead of dx, what do I have? Du over? Yeah, I think you're pretty good. Yay. Just so if you want the answer, what number is this? 27?
Yeah.
They don't do the same thing. They just differentiate. They just flat out differentiate with respect to x. They don't even say they use U substitution.
Did they?
No. It's hard to know what they do because they just do stuff, okay? They just do stuff. I'm going to pause for 1 sec while I ramble. Y equals x squared. What does that look like? Pointed to the right. Pointed which way? Thank you.
It's the thing we've been doing.
The thing we've been doing geometry, yep. X equals 1 and y equals 0. So what are we looking at here? We're looking at y equals 0. That's right here. And x equals 1. So we're really looking at this right here. So this is D. Okay, that's nice. That's D. The boundaries change, exactly. So let's draw this boundary, right? So we know that x is between 9 and y squared, and y is going to be between and 0. Very good, okay? So if we draw this, so with y and x is between 9 and y squared. What does x equals y squared look like?
Parabola going
Which way? Up, down, left, or right? Opening to the right, correct. Okay, so we're looking at a parabola opening to the right. And it's between 9 in that. So we need to actually, so we'll say 9 is, I don't know, right here. Is that okay?
So then you said 3.
Yep. And negative 3, correct. And y goes y is from 0 to 3. So we're just looking at we're just looking at this part right here. Correct? I think that's okay. So we're just looking at this right here. Cool. Okay. So now we have to reevaluate this. I'm gonna make one point. Look at the to figure if you ever get lost in like which order you're doing it in. Look at the outer one, the dx. The dx means the overall slice that you're making is little itty bitty on the x. So if you're making this tower with the little delta x being on the x-axis, your height has to be in terms of this is the height, not side by side. So if this is the height and it's dy, it needs to be in terms of x. Yes, go ahead, Jerry. 3, 0 to 3, 0 to what? Pi? Sounds right? And it's going to be cosine of what?
R squared.
R squared, and it's, I'll turn the R, yep. R dr d theta. There it is. We know that x squared plus y squared is r squared. We're going from 0 to 3 for the radius, and we're going from 0 to pi. That's it. Can you integrate that? U substitution, because that r is on the outside. You can do that. You're going to let u is equal to r squared. You're going to pop out a 1/2 on the outside, nukes the r. You're going to get the integral of cosine u. You can almost do this in your head if you took a minute. This isn't quite as easy. Well, we know the x's go from 0 to 2. That's kind of nice. So let's say that's 1 and this is 2. So we know we have a boundary here, right? And we also know we're bounded in which quadrant? The first quadrant, I think, right? Because we have this, well, we have the zeros right there. X 0 to 2 and 0 to, so the trickier thing is just graphing this. When x is 0, where is it? If x is 0, where is it? 0, right? When x is 1, where is it?
1.
And when it's at 2, where is it? 0. Correct. So could you just plot some more points? You could. In terms, I mean, you graph things like this in AP Calculus. You check for concavity, right? You know, stuff like that, right? Do you want to guess as to what this looks like, or do you want to do a little bit more detail? What do you think? Say that just because the derivative is 0 doesn't mean it. Yeah, but let's just write it out. You end up with 2 minus 2x over 2 times the square root of 2x minus x squared. Can this ever be, that's always positive, right?
Yeah.
So this goes from positive to negative across 1. It does. So it's definitely going to look something like, what do we think it's going to look like? I don't know, something like this. Sure.
Is it symmetric?
I don't know. How could we, it's not symmetric. Well, is it symmetric over the line? I don't know. Are these questions that we need to concern ourselves with? No. Is this the region we want right here?
Yeah.
Yeah, it is. It absolutely is. So how do we go about doing this, though?
So I think we need to use the height of 2.
Well, no, it's asking us to convert. Look what it's asking us to do. What did the question ask us?
Converting it to,
It says convert it to polar. Right? So the first part is really easy because you're going to end up with the square root of what?
R squared.
dr r dr d theta, right? Okay, that's nice. Yay, great. Problem being now, we need to describe this region in polar. How do we do that?
We know that x is r cosine theta.
Okay, so what do we end up with? The square root of 2r cosine theta minus r squared cosine squared theta. Does that simplify at all? What can we factor out of both of them? We could factor out what? I think it's r cosine theta times what? R cosine theta, like this. Which is the same thing as if you factored out the x first. Okay, so that's what that upper function is right there. There it is. I mean, I agree that that's it. The question is, what about the rest of these values here? Just what? Just leave it like that? 1 minus, so x squared plus y squared is equal to, so r squared is equal to 1. But in terms of a graph, what are we looking at? Like that, right? So instead, what do we have here? It's going to be e to the what power? r squared? dr, because x squared plus y squared is equal to r squared. And our radius is going from 0 to 1. And what part of the circle do we have?
0 to pi over 2.
0 to what? Pi over 2. Yep. And if you do this out, what do we have to use?
You have a beautiful R on the
Outside. Does that make things a lot nicer for us?
It makes it possible.
It makes it doable for us. Yay. And you end up with 1/4 pi times e minus 1. Yep. Nice. Cool. How do you do that? You just do this. U is equal to r squared and go from there. It cancels really nicely. Really, 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 really nicely. Okay? Okay, equals 1. Let's say that's right. Oops. Right there. But then you have, I just need x squared plus y squared equals 2y. So you know that x squared plus y minus 1 squared equals 1. Right? So that circle shifted up
right.
1. Up 1.
Y, yes, Y. Yep, up 1.
It's up 1, right?
Right. Oh yeah.
It's up 1, isn't it? Or down 1?
It's down.
So there is.
That's correct, though, right? Yeah, that's correct. Yeah? What do you think here? Well, now, I like it when I get stuck on the... So, yeah, what are we looking at? We're looking at the inside. Our lamina is going to be right here, correct? Like that, right?
Why not the unbounded?
Because it says outside the first one, but inside the second one. You got that?
Inside the first one and outside the second.
This was defined as the first one.
So that's the second.
The first one I drew, the black circle.
The first one you drew.
That's what
is
I
the
meant.
second
That's
one.
what I meant. That's what I meant. That's what I meant. That's what I meant.
You sure that's what you meant?
I am sure. Okay. Okay. That's our outer function. Are we okay with that? What's our inner function? That's just r squared is equal to what? 1. So r is equal to 1. Are we okay with that? So what's our mass going to be? We're going to go for it's going to be r dr d theta, right? The function for our density is k over r. We're doing r first. R is going from 1 to what? 2 sine theta, right? Because the first r remains fixed the entire time. And then what do you have to find, though? You have to find the theta values, right? And the theta values are going to be the theta values at the point of intersection right there, going to this point of intersection. It's going to be symmetric, right? But it's not exactly trivial. Any thoughts as to how we get the theta value?